Welcome to this episode of AI Frontiers, titled Robotics Revolution, Mastering Dynamic Worlds. This presentation synthesizes 7 papers from the arXiv preprint server's cs.RO category, dated September 6, 2025. Cutting-edge robotics research is explored, focusing on machines that adapt to real-world chaos like professionals. Buckle up for a thrilling ride through 7 fresh robotics papers from September 6, 2025. Themes, findings, and future impacts are unpacked like a sci-fi story grounded in science. Discover how robots evolve from rigid tools to adaptive partners in our unpredictable world. By the end, robotics is seen as key to safer, smarter daily lives. Big ideas that could reshape transportation, healthcare, and more are explored. Computer science robotics blends computing with engineering for autonomous systems that sense, decide, and act. Key elements include sensors as eyes, algorithms as brains, and actuators as muscles for real-world interaction. Impacts span warehouse automation, self-driving cars, surgical aids, and exoskeletons for mobility. Challenges such as handling chaos, ethical AI, and cost barriers drive ongoing innovation. These 7 papers build on embodied intelligence, focusing on dynamic environments and human-like adaptability. A key theme is teaching robots to predict chaos, like chess in traffic. Lin et al. Use game theory for autonomous driving, modeling vehicle interactions in roundabouts. Risks are reduced by anticipating human moves, enhancing safety in real roads. Strategic models are built for non-scripted scenarios. This theme fuses sensors like LiDAR and inertial units for accurate 3D mapping. Wang et al. Super-LIO optimizes for low-power devices, enabling efficient drone navigation. The technical concept of sensor fusion combines data streams to reduce errors in noisy environments. It is vital for robots in tight or dynamic spaces like disaster zones. Focus is placed on intuitive controls and natural robot behaviors for collaboration. Kalliokoski et al. Explore shared control in telepresence, easing user guidance. Flores Alvarez et al. Apply reinforcement learning for stable walks in quirky humanoids. This extends to detecting tricky objects and optimizing paths in clutter. Zhang et al. Detect transparent glass via monocular 3D fusion for collision avoidance. Siyuan Wang et al.'s hybrid A*PRM shortens paths in dense areas efficiently. These themes connect, showing robotics as an integrative field for practical solutions. Game theory boosts driving adaptability by 20 to 30%, reducing collisions, as shown by Lin et al. Sensor fusion cuts processing time by 73% for low-power mapping, according to Wang et al. Hybrid path planning shortens routes by 42% in clutter, from Siyuan Wang et al. Shared control matches efficiency without extra workload, per Kalliokoski et al. These leaps enable safer, more efficient robots in real-world chaos. Game theory models interactions as strategic games for adaptive decisions. Sensor fusion integrates LiDAR and inertial data to overcome individual sensor limitations. Probabilistic roadmaps with hybrids like A*PRM optimize paths in complex spaces. Reinforcement learning uses rewards and priors for stable, natural robot movements. Trends favor hybrid methods, balancing scalability and real-time performance. The full title is Scenario-Based Decision-Making Using Game Theory for Interactive Autonomous Driving, a survey by Lin et al., 2025. It is selected for its impact on safer autonomy through game theory surveys. Novelty lies in categorizing scenarios like highways, guiding real-world AI integration. It represents the decision-making theme with broad transportation implications. The full title is Super-LIO, a robust and efficient LiDAR inertial odometry system with a compact mapping strategy, by Wang et al., 2025. It is chosen for novelty in lightweight mapping, democratizing robotics for low-power devices. Impacts include navigation in drones and mobiles, representing the sensor fusion theme. High representativeness is noted for efficient, real-time applications in dynamic environments. The full title is Learning to Walk in Costume: Adversarial Motion Priors for Aesthetically Constrained Humanoids by Flores Alvarez et al., 2025. It is selected for innovative reinforcement learning in adaptive locomotion, blending aesthetics and function. A novel approach to humanoids in entertainment represents the interaction theme. It highlights key directions in human-centric robot design with broad appeal. Multimodal AI is scaled for better sim-to-real transfers and edge computing. Ethical access and computational challenges are addressed for intuitive, collaborative bots. Gaps in perception for invisible threats and dynamic human interactions are bridged. Hybrid systems are explored to redefine work in healthcare and disaster response. Potential exists for robotics as lifelines in aging societies and climate challenges. This deck was synthesized using AI tools. GPT Grok with model Grok 40709 for content generation. TTS synthesis was handled via OpenAI for voiceovers, and image generation used Google tools. It underwent review by a human expert to ensure accuracy and coherence. Some oversights may exist. All references are provided for verification. Subscribe to the YouTube channel for more gripping AI research stories. The title is AI Frontiers. The description is Stay updated on robotics revolutions and beyond. Hit subscribe now. Share your thoughts and dive deeper into the future of tech. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.